All right, what's cracking? It's time for ratio test. Last test. Last test. And it's a doozy. It is a doozy. I love the ratio test. All right, so what do you need to have? You need to have a healthy respect for infinity, of course. You need to be able to do limits at infinity, of course. And you need to be able to tell if something is bigger or smaller, of course. What else do you need? Oh, you need to subscribe to the channel. You need to hit the notification bell. You need to do all that stuff. What are you waiting for? Come on. All right, let's take a little trip down memory lane. What's the sum of this series here? 5 halves, plus 1, plus 2 fifths, plus 4 25ths. It's geometric. Yo, that is geometric. Now, the ratio is 2 fifths. Well, that's less than 1. That means it's a convergent geometric. So the sum would be the first term divided by 1 minus the ratio, right? So we take the first term, 5 halves, divide by 1 minus 2 fifths. That's 3 fifths. We multiply by 5, 25 6. Got it. Now, why are you bringing up old stuff? Why are you bringing up old mathematical truths? Why? Oh, maybe because all new math is just old math repackaged? Maybe. That's right. Ratio test is connected to this old stuff about geometric series. Now, there's a lot of series out there that are like geometric series, but they're not really geometric series. They kind of have a common ratio, but they kind of don't. Case in point, the Fibonacci sequence. Now, y'all know the Fibonacci sequence. Come on, 1, 1, 2, 3, 5, 8, 30, like keep going, keep adding the two previous numbers to get the next number. This recursive sequence that's like famous, okay? If you don't know the Fibonacci sequence, what are you doing? Come on now. Well, did you know that in the Fibonacci sequence, if you take the ratio between one term and the term right before it, you get further along into the Fibonacci sequence, and that ratio approaches the golden ratio, phi. That's right, the golden ratio. Well, you mean you don't know the golden ratio either? Come on, man. The golden ratio. Oh, my God. That's pretty awesome. Maybe you didn't know that. But the Fibonacci sequence is one of those sequences that's not really geometric, but it kind of acts geometric. So there's other sequences and series out there that do the same thing. They're like geometric, but they're not really. And that's where the ratio test comes along. So each of these series right here, not geometric, not geometric, not geometric, none of y'all are geometric, but with the ratio test, I can see if you act like a geometric. Okay, so here is what we're going to do. We're going to see what happens to this ratio. We're going to take the n plus 1th term, so a sub n plus 1, and divide by a sub n. Okay, so we're going to take the ratio between any two terms generically in the series. We're going to take its absolute value because we don't care about positive or negative. If it so happens to alternate, that's not going to blow things up. Now, I call that a pseudo ratio. It's kind of like a ratio. It's not a common ratio, but it's a pseudo ratio. Now, as you push n to infinity, you want to see if that is heading to a value, that pseudo ratio value. As long as that pseudo ratio value is less than 1, then it acts like a geometric series whose common ratio is less than 1 and therefore converges. That's kind of what we're doing with the ratio test. So let me show you what it is. So here's the ratio test. Bam! Let n, the limit as n goes to infinity of this n plus 1th term divided by the nth term. Do the absolute values. Don't worry about any negatives, right? If that goes to L, if L is less than 1, the series converges, and it does so absolutely. We talked about that last lesson. If L is greater than 1, so if this ratio is greater than 1, then it's a slam dunk. The series diverges, And if the limit is equal to 1, ratio test don't tell you nothing. The ratio test is inconclusive. Okay? So let's show you a few examples and we'll be on our merry way. This is a great test for like things that are a mixture of all the types, like polynomials, exponentials, factorial. You haven't seen factorials a lot so far. So if you see factorials and a combination of these different function types or sequence types, then the ratio test is a great one to use. All right, so here I'm going to do each of the three that I showed you before. So 2 to the n divided by n factorial. So we're going to set up ratio test. Here we go. So we want the n plus 1th generic term divided by the nth term. So we're subbing in n plus 1, right? So this is 2 to the n plus 1 over n plus 1 factorial divided by 2 to the n over n factorial. I save you the pain, right? Dividing by a fraction, the same thing as multiplying by the reciprocal. So I'm multiplying by n factorial over 2 to the n. Well, let's see how things cancel out. I love it. We can hi-ya a few things in there. 2 to the n plus 1 over 2 to the n. Hi-ya! It's just 2. Now, n factorial over n plus 1 factorial. Think about how factorials work. You might need a little crash course in factorials. I don't know, but n plus 1 factorial is n plus 1 times n minus 1, and then everything down to 1. Well, that's what n factorial is, right? N plus 1 factorial contains n factorial. So all those terms cancel out, just leaving us with a 1 n plus 1 factor in the denominator. Well, the limit as n goes to infinity of that ratio, 2 over n plus 1, goes to 0. Well, what does that mean? Well, 0 is less than 1. And that means 2 to the n over n factorial converges by the ratio test. Pretty nice. Let's look at another one. Oh, before we do, though, bogus thinking alert here. Make sure you do the n plus 1th term divided by the nth term, because if you flip that around, you're going to get numbers that should be less than 1, but if you do the reciprocal, you're going to get them greater than 1, or if they should be greater than 1, you're going to do the reciprocal and get them less than 1. So you got to be careful how you set this up. It's got to be the n plus 1th term divided by the nth. And you got to sub in n plus 1 in place of n. People make the mistake all the time. They just see an n and they just add 1. That's not what we're doing. The n plus 1th term is subbing in n plus 1 in place of n. So those two just words of caution there in case you come up with those bogus ways of thinking. All right, so n squared over 4 to the n. Let's talk about that. Well, all right, that's a combination of polynomial and exponential. Let's crank through the ratio test. So here we go. The n plus 1th term is n plus 1 squared over 4 to the n plus 1. I'm going to multiply by the reciprocal, save myself a step. That's 4 to the n over n squared. Hi-ya! 4 to the n over 4 to the n plus 1 is just 4. Now, n plus 1 squared does not hi-ya with n squared. Don't make the silly algebra mistakes that lesser mathematicians make. N plus 1 squared over n squared does not simplify like factorials do. So that's why it's still there. But they're the same power. So essentially, at infinity, they'll go to 1 because they're n squared over n squared. So the limit as n goes to infinity of this ratio is a 4th. What does that mean? Oh, that pseudo ratio is less than 1. And by the ratio test, it means that that series converges. All right. Rockin' and rollin'. How about this one? Negative 1 to the n times n factorial over 2021 to the n. That's because I'm making this video in 2021. In case you're watching this in 2046. I'm Eric Purvis. I was a genius math teacher. All of the schools now that I have created across the country, this is where they started. So, hi future people. All right, so the ratio test Because we're doing the absolute value, right? The absolute value of that ratio. Let's just chuck the -1 to the n out, right? Because it's not going to matter. It's going to simplify to -1, and it's going to be thus 1 when we absolute value it. So we'll just chuck it out. So the n plus 1th generic term divided by the nth generic term looks like this. N plus 1 factorial over 2021 to the n plus 1, multiplied by the reciprocals to save myself a step. N plus 1 factorial over n factorial is n plus 1 in the numerator. And then the exponentials cancel out nicely to just be 2021 in the denominator. At infinity, that goes to infinity. What's that mean? Oh, that's bigger than 1. By a little. It's a little bit bigger than 1. And since that's bigger than 1, the ratio test says that series diverges. Man, ratio test is powerful. Okay, here we go. One more here. I want to show you. This one's going to be inconclusive, just if you were paying attention. So this is just a polynomial over a polynomial. N plus 20 raised to the 21 over n to the 2021. So all we got is n to powers. So I want to show you that the ratio test is not just like the thing that's going to save your bacon every time you get to something you don't know what to deal with. So look at the way it works out. You get the n plus 1 term multiplied by the reciprocal there. Well, the powers are the same in the numerator and the denominator. Right? The powers are, what is it, 2042 on the top, and the power is 2042 in the denominator. That means the ratio is 1. And if the ratio is 1, that's inconclusive. Okay? So don't say that that converges or diverges. That just means the ratio test is not the test you want to use for polynomials over polynomials. You want to use limit comparison. Limit comparison was a great test because it kind of condensed all the powers to a p-series that it kind of acts like. And by the way, that converges because the power difference there is 2,000. And that's certainly bigger than 1 as a p-series. Okay? So there you go. There's the ratio test. Man, what a ride. So the ratio test says this. We're going to find the limit as n goes to infinity of the absolute value of the ratio between the n plus 1th term divided by the nth term. If that's less than 1, your series converges. If it's bigger than 1, your series diverges. And if it's equal to 1, the ratio test is inconclusive. And again, one last little fact is that series that you get to be convergent with the ratio test are absolutely convergent. So if you're worried about absolute and conditional convergence, this is another way to tell if something is absolutely convergent. All right, that does it with series tests. Next time, we're going to get into Taylor and Maclaurin polynomials. Man, y'all just buckle up because that's going to be a ride you will not forget. All right, peace out, everybody.